Hello, my name is Waranya Thiantharworn. My ID is 6701161011291, and the data that we need is the last 5 digits, and I transfer it into the binary, and we got 0110011 in the binary number. And for these circuits, we need 3 inputs, which is CS, SCK, and MOSI. MOSI is our data, which is this number. And to create, first of all, we need to check the CS, which is the first digit of the 3 of this. For the state 0, it needs to be output 0. We're gonna check 0xx, which is don't care term, but if it's turned 1xx, the state is still on the 0 state. And the next state is the state 1. The output needs to be 0, the same, but we're gonna check the 1xcs, 1xx. If the CS return 1, it's going to the next state. But if the CS still on the 0xx, is gonna stand still on this state 1, which is the loop. It cannot go to the next state. So the next state is state 2. The output needs to be 0, and we're gonna check the SCK, which is the next digit, the second one, the middle of the 3 of this one is SCK. And if the SCK is 0, it's going to the next state. But if the SCK is still 1, it's going to be this state, the state 2 is not going to the state T. We're gonna check our data, which is which is 110. And the state, if it's still 10x, which is from the state 2, is going to loop at the state 3, is not going to the next stage. This one is from this one. And then to go into the state 3, the state 4, it needs to be the very first digit of the binary that we has transfer, And if we got it, it's going to turn into the state 4 for the next state. And of course, if it's still 1, 1, x, it's going to be loop like on the loop of this state. But if it's swap into the 1, 0, x, it's going to the next state, which is state 5, also 0. And as is the state 4, if we got 1, 0, x, it's not gonna go to the state, the next state. It's going to the decently state, which is state 5. And then to move to the next state, the state 5 need to get the data 1, 1, 0. No, 1, 1, 1. It is the second one, and this. As I have said, the MOSI is the daughter. Which is the last digit of this 3. And then next, state 6. If it's still 1, 1x, it needs to stuck on this state. And to go to the next stage, the state 6 need to get 1, 0, x. Okay, to check it. And the state 7. If it's still turn 1, 0, x is going to stop on this state. But if the state 7 is get the input from the binary in the third digit, which is 1, we're gonna have this 1, 1, 1. 1 and 1. Sorry. Okay. And to the next stage, which is state 8. If the output is still 1, 1, x, is going to stuck on this state. But if it's changed into the 1, 0, x, it's gonna move to the state 9. Okay, and we also checked if it's still 1, 0, x. And to the move to the state 10, we need 1, 1, 0. Now we have the fourth binary. We still have the 3 of this that we didn't have it yet, so we're gonna fast forward to it. and check it if it's still 1 1x. To move to the next state, we need to change it into the 10x, and if it's still 10x, is going to stop on this state, and to move to the next state, we need 110. State 12. If it's still 1x, it's going to stop on this stage. But if it's changed into the 10x, it's gonna move to the stage 13. And if it's still 10x, it's gonna stop to this. And to move forward, we need another 1. State 14, we need to check if it's 10x. State 15, we need to check if it's 10x. But if it's not, it needs to be 1. And then the state 16, it needs to be 1. The output needs to be 1. Okay. And then the state 17, the output needs to be 0, because we're gonna check if CS is 1. So we're gonna build the algorithm for state 16, 17, and 18 and 19. We're gonna check the CS. If the CS from the state 16 is 1, and we don't care about the SEK and MOSI. If the state 17 is the output is 0, it's gonna turn back to the state 16 and swap it. And also in the state 19 and 18, it's all the same, but change the CS into the 0 to check the CS 0. Don't care. The state 19 and 18 are the same as 16 and 17. And if the state 16, if the state 16 is 0, the CS is 0, you can turn into the state 19. And if the state 17 is the CS is 0, you can jump into the state 18 also. We can forward to this because this is like a square wave. This two algorithm is to create this square wave, like a clock. Okay, and then if the state 19 and 18 to go into the next state, it needs to be 1xx. So the 1xx is the state 2 to like to turn these circuits again. So it's going to be this state diagram again if it's turn 1xx, and then we're going to create the lines of the wrong data that has come into this. What's going to happen if all the signal data has created the wrong one? The input has state 3, 5, 7, 9, 11, 13, and 15. This is all the data on this diagram, and if it's wrong, it's going to turn into the state 0. What kind of data that is incorrect? For the security, the input shouldn't be 111. It is the wrong 1110, 110, 111, 111, 110, and 110. This is the wrong data input. It's going to turn into the state 0 again, but if it's wrong because of the CS, where the state that it's going to loop again, the CS, all of the state if it's go wrong, if this CS go wrong, like in this case, if CS is turned 0 xx, the state, every state going to turn to the state 1 to check the CS again if it's 0, or 1 if it's 1 is going to the next state. So this is all the state diagram